Hello, today we're going to talk about 4-5 scatter plots and trend lines. We have quite a few vocab words today. I believe that you've seen scatter plots before. They're pretty common. A scatter plot is a graph with points plotted to show possible relationships between two sets of data. And scatter plots have different types of correlations. Correlation is a relationship between two data sets. So there can be positive, negative, or no correlation. In positive correlation, both sets of data values increase. In negative correlation, one set of data increases and the other decreases. And then in no correlation, there's not a specific relationship evident between the data. And then the last thing we're going to talk about today is called a trend line. That's also known as the line of best fit. And this is a line that you put on a scatter plot to help show correlation more clearly. So the first thing you're going to be doing today is making a scatter plot. Now I know that you've done this before, so we're not going to spend a whole lot of time on it. It'll give you a table, and it will just want you to create a scatter plot of the table. So the first thing you're going to do is label your axes. So we're going to put time down here on our x-axis and cookies up here on our y-axis. Okay, so time, it looks like this is number of days since the cookies were baked. So 1 day, 2 day, 3 day, 4 days. And then how many cookies are left in the cookie jar. Looks like we have to get all the way up to 24. So let's see, let's count by threes. 3, 6, 9, 12, 15. Okay, and then all we're going to do is plot our ordered pairs. So 1, 24, 2, 16, it's going to be about right here, 3, 10, and 4, 7. So the more days that go by, the less or the fewer cookies that we have. Now scatter plots, we don't connect the dots, we just plot the points. So this would be my scatter plot of the data. Once again, I got to remember to label my axes. And that's how we make scatter plots. Now the next thing is correlations. So here I have pictures of the 3 types of correlations, and you'll want to make sure that these pictures make it into your notes. So in a positive correlation, you can see that the general trend of the dots here is that they're going up. So as x goes up, y goes up. So both sets of data are increasing. In the negative correlation, you can see that as x gets bigger, y decreases. So that's called a negative correlation. And then in the third picture here, we have no correlation at all. And as you can see, the dots are all over the place and there's not a general trend. So what will happen here is they'll give you pictures of graphs and say, what's the correlation? And you'll just have to say whether it's positive, negative, or no correlation at all. Next thing is we have situations where we try to identify what the correlation would be. So here's our first example. The average temperature in a city compared to the number of speeding tickets in the city. So we have the temperature in the city and the speeding tickets in a city. And do you think that the higher the temperature is, the higher the speeding tickets? The lower the, or no, the higher the temperature, the lower the speeding tickets? Or do you think that they are unrelated? Now, I know that you could all probably make an argument for either of these, but I think the majority of the time this would not be related. Okay, so we would say, actually we shouldn't write none, we should just write no correlation. let's look at another situation. The number of people in the audience and the tickets sold. So, do you think that the more people we have means the more ticket sales, or the more people we have, the lower ticket sales, or do you think they're not related? Well, hopefully you think the more ticket sales, the more people. So that would be a positive correlation. They're both increasing. Okay, and then how about this? A runner's time and the distance to the finish line. So again, we think through this. Do you think the longer a runner runs, the shorter the distance to the finish line? Or the longer a runner runs, the longer the distance to the finish line? Or do you think it doesn't matter? How far they run and how close they are to the finish line doesn't matter. Hopefully, you think that the longer the runner runs, the smaller their distance to the finish line is going to get, because they're going to get closer and closer and closer to the finish the longer they run. So their runner's time would be going up, distance to the finish line would be going down, so one increasing, one decreasing, that would be negative correlation. And you can see here as how I kind of just talk myself through these situations. Ask yourself, okay, are they both increasing at the same time? Is one increasing and one decreasing? Or is there no way to tell? Okay? So you'll be conquering some situations in your homework. You'll also be looking at something like this. Here they give you a situation and possible graphs. And they want you to choose which graph makes the most sense. So let's label these graphs A, B, and C. Now our situation here is the age of the car and the amount of money that we spend each year on repairs. So, first of all, if we look at graph A, something should kind of pop out at you that something's wrong. Okay? Tell me when you see me next what you think's wrong with A. But there's something wrong with A that makes it not a good choice. Okay, so that leaves us with B and C. So B says that the older the car gets, see here the years increasing, the cost is increasing. So the older the car, the more you're going to spend on repairs. Graph C says the older the car, the less you spend on repairs. So which one do you think makes sense? Well, hopefully you're thinking that graph B makes sense. Typically, the longer you have the car, the more things that are going to break and the more you're going to have to spend. So notice here that it says to explain our answer. So we would choose graph B and we would say some sort of explanation like the older the car, the more repairs you'll have to have. Or as the car gets older, you'll have to repair it more, or something like that. Okay? So on these, you would choose a graph and you would explain why you chose that particular graph. And then the very last thing today we want to talk about is trend lines. So when we have a scatter plot, we can put a line on the scatter plot to help show the relationship. And this function is a straight line. We call that a trend line. This helps us to see correlations more clearly, and it also helps to make predictions, and that's the main thing we'll be using it for, is to make predictions. So here we have a scatter plot that shows the number of orders placed for flowers before Valentine's Day at one shop. Based on this relationship, predict the number of flower orders placed on February 12th. So, if I look at my graph, what I would do when I draw a trend line is I want to try to make it go through the middle of my data points. It doesn't have to touch every single data point. I just want it to go through the middle. So I want to have close to the same amount of dots above the line as I have below the line. Now, one common mistake is people think that they always have to start at 0, 0. And that's not true. Okay, you can start your line based on where your data is at. So here, I might start my line down here. I'm going to try to make my line go through the middle of the data as best that I can. Okay? And each trend line that you draw is going to be a little bit different, and that's okay, but we should end up with the same, close to the same estimates when we estimate for how many orders are going to be placed on February 12th. So on these, we draw the graph, draw the trend line, and then we're going to use estimation, similar to what we did in the last section that we talked about. I'm going to go up from February 12th until I hit my line, and then I'm going to go over. Let's see, this would be 35, 40, so I'm going to say about 42 orders for my prediction. Okay? So that's how we use a trend line. So just a review here real quick. We talked about how do we make a scatter plot. We did that first. Remember to label your axes, don't connect the dots. Then we have our 3 types of correlations that we'll be able to say which scatter plots have which correlations. Then we'll have situations to think about and name what kind of correlation we would expect. Then we'll have situations, we'll have to match them with graphs and again explain our answers. And then finally trend lines, where we'll be given a scatter plot that we will draw our trend line in, and then use that trend line to help us estimate what will happen in the future. Okay? So that's all for 4-5. We'll see you guys tomorrow.